Hi, good morning. I'm shooting a bit of a preface for the video that you're about to watch because it's a little bit, I wouldn't say complicated, protracted might be the right word for it. I've been working away on two essential problems with this radio. One of them is, why doesn't the broadcast band operate? And you're going to hear in the video that previously I discovered through an awful lot of effort and proved that there's an open coil up here blocking the antenna signal from getting into the radio any distance at all. So I can't fix that. It's too deep down here. I can't get at it. It's just the broadcast band. I've sort of written that off. So that took a couple of days to do, which I did not post any videos for. I then started pursuing this problem with the tone switch down here, or it appears to be with the tone switch, where when you turn the volume down, the radio begins to motorboat and oscillate in various ways. During the course of my investigations, which you're going to be watching a bit of because I didn't video everything, I found a capacitor here that I had to change. I put this capacitor in 3 years ago. It's 10 times the size it was supposed to be. So a mistake on my part. I corrected that. No bearing on the radio. Didn't have any effect. I've studied all the wiring in here. As far as I can see, it's all correct. I cannot find anything wrong in this switch. And this switch is really, really difficult to analyze. And then most recently I found a resistor that had gone way high. Here it is. Took it out of the radio. That's the last thing I did. So I'm not going to say much more. You can watch the video here, and I'm really not sure what this video is going to look like, since it's really shot over 3 or 4 days of me running in, doing little bits, and then running out disappointed. That's kind of how it is. So here comes the video. Well, hi, good morning, and welcome to my shop here. It's April 14th. I did not post a video yesterday. I was in here yesterday morning, and I worked away at the problem of what's wrong with the broadcast band in this radio. And I determined that there's an open coil just beyond these antenna connections that is wrecking that part of the radio, basically, and everything is buried way down in here and really can't get at it. And I spent a long time proving to myself that that's the problem. But I'm not going to bother posting a video because the end result is very simple. Open coil on the broadcast band. That's not going to work. Okay, so what I want to approach today is this. What is that? Now there's no antenna on the radio, so it's very quiet here. Let me just put an antenna on it. Me. Something else going on right there. But if we turn it all the way down, we get that. This has been absolutely consistent the whole time I've been working on this radio, and it suggests to me that it's the result of an incorrect component placement. I made a mistake. 3 years ago when I was fixing up this radio, I'm going to guess I made some kind of error, probably in the componentry down in here, and that's resulted in this motorboating and an inability really to turn the radio down. Can't really turn it down because once it comes to life, it's got a lot of volume in it. And then there's this tone effect going on too. So all of it, I can take a pretty good guess, is of my making. So I hope to unmake that. A bit of a challenging deal because it probably involves the components down in here on this switch. Yeah, so I'm going to stop shooting video. I'm going to study as much information as I can about the switch, about everything, do as much as I can off video. Because if I could sort this out quickly, then I would just move on to the final alignment of the radio, which is really what I'd like to do. Okay, let's take a look at the schematic here. Here's the speaker. You can follow this wire down from the speaker, comes across here, goes into the bottom of the 1 million ohm volume control. top, assume this must be the input end of it. Got a capacitor to ground there. Got a resistor capacitor network going into a switching arrangement. So this feedback line, follow it again. There's two takeoffs here. This is very important. One feedback takeoff goes into this switch. Out of this switch there's only one wire, and that's this one. And that comes up to the, I often don't know what to call it. I call this the back tab. That's my personal name for it. See, they don't have an arrow here, just a dot, because this is a fixed in point, fixed in place thing. So feedback of some sort gets to here through this switch. Okay, the other feedback wire here comes down, goes over to this switch. What comes out of this switch, it depends upon how it's switched, all kinds of weird combinations. Here's something going to ground, or to the B minus. Here's three settings that do the same, but one in the middle doesn't. It's coming up into the backside of the output of the volume control, if I can call it that. Backside. So it's actually kind of feeding right at the grid here. So as I've said many times, this part of a radio, the tonal control network, which in some cases is very simple in radios, in other cases can become this kind of thing, is a masterpiece of the engineer who designed it. This is his baby. This is what he was talking about at the coffee table. You know what I'm going to do with that radio? Well, I'm going to run the feedback through two separate switches. That's going to give me the one that I'm going to be able to do it, and the sound will be fantastic. That's the kind of conversation that would go on. So this switch and this switch are fed from feedback. You can see onto the center ring. Feedback onto the center ring. What's this switch doing? I mean, these are all on the same shaft or the same wafer switch. What's this switch doing? It's either open or closed on 1, 2, 3, 4, looks like five settings. Closed on 5. So if we look at where this is going, or where it's coming from, this is the coming from wire. Where is it coming from? It's all the way up to B+. So B+ comes down this wire, reaches this switch. Now this is supposed to be in broadcast mode. The switch is open in this position. I'm going to get a little quiet from here because the B+ comes up here, branches on this wire. There we go, up here. It's actually a screen voltage being applied here. Is this all screens? Come over here. Come up, look carefully. Yes, those are screens. And you got to guess this comes over and comes down and picks up the screen. So you have a switch here which turns on these screens, but not for every band. There's a switch here. So you can imagine when you have the radio in phono mode, it kills these front end tubes by opening the feed to the screens. You can imagine that, but it's not closed all the time, so that suggests, well, this is a tone control. It's not a band control. Tone control, right? There isn't 7 band settings here. There's just whatever tone control settings they have. And what do they have? We're going to look into this in a second. We're going to operate the switch and see what effect it has on everything. So, for me to analyze this and to understand fully what is going on, I think, that might just carry me right to the grave trying to sort this out. You're probably going to have to get the engineer from beyond and bring him back here and say, what were you doing here? Look at this. There's two contacts in this switch, which is unusual. And what is this switch? So this switch is in part of the tone control, but it's not fed from feedback. Look, interestingly enough, PU. I think that means speaker out the back. No, LS means speaker. PU means probably something unit, player unit. Probably a record player is probably what this is. It's probably an input. That's an input. Well, whatever gets on this ring goes out this wire, goes through this curious little network of what, I don't know what, switches, goes through these two capacitors. Oh, in some cases, looks like somehow you short this one and bypass it through here. So sometimes you've got 34 in and sometimes you've got these two in, I think is what's going on here. And where's it go? Goes through here, has a filter with this R10 C30 thing going on, and then it goes up and it's the input to the volume control. Well, that didn't make sense. If this is the cartridge on a record player, yeah, it zoom right up to the top of the volume control. At the same time, you'd be breaking, you would want to break the audio from the radio in this switch, probably in this switch. Well, where is the audio from the radio? Let's just follow that out. So down here, so we got a filter here, and the audio is coming, yeah, it's heading for this switch. So here is the audio on here from the radio. So if you rotate this, oh, well, that's interesting now. I'm not going to be able to, yeah, you rotate the switch, these two diamond things are moving. And so I apologize now if there's been some telephone interference on my video. I've had my phone in my pocket all this time, so I hope that didn't happen, but okay. So here we've got an input or an input. No, that's not, yeah, input here. So I have an input that catches these four, or two, yeah, two for the record player. There are two positions in the record player. It's basically a high tone, low tone. So you have two of these tone control positions are really for the record player. And that could be dramatically different, how they handle the tone from a cartridge versus how they're handling the tone from the output of the radio. Cartridge is a bigger problem, kind of. You have to manipulate the tone more to make it sound nicer from a cartridge, I believe. You know, so now we got this figured out a fair ways, except I don't understand the volume control. It's got an input coming from the bottom, from the feedback line, from the speaker, and it's got an input on the top coming from, yeah, sure, coming from the radio or coming from the cartridge. Yeah, that makes sense. Okay, and we got a pile, we've got some feedback that can make its way into here under certain circumstances. Feedback. And what kind of noise are we getting? We're getting motorboating noise. Motorboating. Put, 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 put. That's usually something to do with the AVC. Voltage going up and down, that's the actual oscillation. It's just extremely slow, you know, one oscillation a second type thing. So where is the AVC system in this radio? It's separate. It's quite separate. So what they've done here is on the secondary side, they take the audio off down here. But in order to provide an AVC voltage, they use this diode and they've connected it. He's connected it. Rather than the output here, he's connected it here. This is a powerful spot to pick up something. Very low impedance here. It's a good place to go get some juice. This is coming down here. Oh my gosh, look at this. This is coming out here and over to here. Oh my gosh, this is just blowing my head off. And into here. So what's he doing here? How does this work? Let's stick with the audio side here, which I believe is the audio side. Yeah, the only thing that can be on this wire is the rectified result of this, because this guy is coming from a different source. They're not you know, working together. Often a lot of radios, these work together as a full wave, or they're just parallel for a big honkin' half wave rectifier. Now what? Right, so audio coming here. This will also be one of the reasons when I tried to pick the AVC off of this spot. Why wouldn't it work? It's coming right here. I put my AVC meter here and got nothing. Oh no, over here, not here. I was over here. Yeah, and the only thing that can get here are AC signals, because all these capacitors are in the way. Right, and then I moved it to here. So this is where I'm taking the AVC off of now. Oh my gosh, I shouldn't. I should be taking it off here. Maybe I'm wrong. That could be wrong. I can't remember what I did. But that's true. When I go to watch the AVC, I should really get off of this and get on here. Now, so this is the AVC voltage down on this wire. The AVC is fed up here through the secondary to the grid. Yeah, this is AVC down here. AVC up to this tube grid, and AVC up to this tube grid. So the feedback for the motorboating can be, I think, all kinds of combinations here. You know, it could be out of this tube and leak back into this tube, or that kind of thing, or something like that going on. Exactly what's pretty hard to figure out. A little more experimentation. I think I've seen enough of this now. What I'm going to do is experiment with the radio and just see under what circumstances you get the motorboating and what circumstances you don't. Okay, radio's on proper voltage. And we are on the first audio position. Double check. Wrong way. That's off. Okay, there we are. First position. I'm going to stick a little antenna on there so we have some noise to hear. Just any old thing. So there's the changeover point. I'm going to leave it right in the middle of it, and we're going to move this tone control. Getting darn quiet. That's interesting. So that's record player low, record player high, radio something again. One more, it's off. Right, I don't want to turn it off. Okay, so now we're going to put it up a little bit and do the same thing. Just go through the bands. Radio. Radio. Oh! Oh, I didn't realize that. See, I didn't realize that was happening. Boy, this is really screaming. There's a part in the wrong place. That's what this is yelling. That's what. Something going on there too, a little rumble. So we have a really weird, a really strong hum feedback coming from two settings. One is phono and one is radio. And it's which phono? It's the last position. That's easy to find on the schematic. Okay, let's do this now. We'll go to the last position. And we'll go through them. That was interesting. So, can you deduce? It's the same. It's the same. Something happens. Same. That's phono. Phono. That's obviously a capacitor charging up. Well, I think it's a capacitor charging up. So all radio are the same on the bottom when this is down and when this is up. What happened? I thought we got to go up high enough. Okay, let's go after this first one. Wild hum on the two. Wait a minute, I got it wrong. Right, I got it wrong. So that's wild hum on the phono 1, phono 2, nothing. Radio, doesn't this one hum? Get it right. 1, phono, radio. Okay, second one in on the radio. Second one in on the radio. Oh boy. Okay, I'm going to stop and I'm going to study that schematic. See what I can figure out with that information. Now I decided to bring you along for the ride here. Okay, so we can start with this switch now. This is the one that's selecting either cartridge or radio, and the radio is actually set to cartridge right now. In the cartridge position there are 2 spots. This diamond is what's moving when you rotate the switch. You get 2 spots. It's actually shown. This is supposed to, yeah, it's shown in the broadcast position, but that has nothing to do with this control. Do they say which control this is in? Here, right over here. What's it say? All switches shown in fully anti-clock position. Example. Wave change switch S1 on broadcast band. Tone control switch S2 in off position. Well, okay, it's off. So this is with the radio off. Really? Really? Am I reading that right? It's in off position. Shoot. Well. Okay, so we snap this control one snap, one way. Which way? Which way would it have to go somewhere? Well, first thing we're doing is we're turning on the radio. So if we snap this way, these would join and we'd have screen. So this has to go this way. But unfortunately, you know, this could be shown, I don't know how they showed these. This could be shown as the back, it goes this way. Oh my gosh, they didn't give any information about that. There's a little extra note there, as C17 and 18 have negative temperature coefficients. Watch out for those. Oh, all switch sections viewed from front and rotation clockwise. What do you mean by that? And rotation is clockwise? Is clockwise. So now that would be convenient to look at the schematic if they positioned all those switch diagrams so that they all rotate the same way. That would save a certain number of brain cells. So maybe that's what they mean by that. Viewed from front of the radio. And so for that to be the case, this is like an X-ray view. This would be a front view. Well, I don't know. Is this on the back? 2A, B, C, D. I'm looking in there. There are 2 wafers at front and back. Just 2 wafers. So there's an A. Oh my gosh, they didn't. Well, you could assume it's A and B and C and D. Oh boy, I'm not going to worry more about that until I have to. figure it out. Do I have to? What am I looking at the schematic for? Help me. The room effect is just, I'm getting overwhelmed here. Just from looking from one part of the schematic to another. Okay, calm myself down now. So we know this is in the off position. And we think turning it on means rotating it clockwise, because over here it says fully anti-clockwise. So you can't go any more anti-clockwise, got to go clockwise. Now the problem is I got it on phono, which is which would be, so so the knob has the information on it, mounted right on the knob. Here it is. Okay, I got the knob in my hand now. Tone control knob. So off, FIDBRIMEL SW. I can't read the last thing there. The last two things are for the record player. It's high and mellow. It looks like something like that. High and mellow. So oddly enough, we have off, fidelity, bright, melodious, I suppose, short wave. A special setting for short wave. I knew all this. I'm just reminding myself of everything I once knew about this radio. So, so we have melodious that appears in two places, and you know what? Those are the two humming places. And melodious appears in the very last position of the record player. Okay, back and looking at the schematic again. Very last position. So how do we know that? How many turns, how many spots are there? How many positions are there? There are, including the off, 1, 2, 3, 4, 5, 6, 7 crazy positions in here. 1, 2, well, start starting with 1, with it turned off. 1, 2, 3, 4, 5, 6, 7. So we go, with it off, this is open. And we snap it once, this is closed. Once it's closed, it's on FID. So we go once FID, once bright, once melodious. This is the melodious setting. Well, on this switch it's nothing, right? But it's 1, 2, 3, I think it's 4. So here, so if we do the same thing here, 1, 2, 3, 4, we get into these two things. But you know, I can snap back and forth, and there's quite a different effect. I don't think it's related to these two things. We're going to do this one. Okay, so this guy would go 1, 2, 3, 4. Now he's found. I see that the problem is while I'm turning this switch and changing its stuff, this one's moving, they're all moving. I'll never be able to analyze this unless I spend the whole day doing it. There's got to be a different way to sort this out. The two settings, let's go back to the two settings that really hum, and one is the last setting. So if we look for that, so okay, 1, 2, 3, 4, 5, 6, 7. So at that point, this has come all the way around. What the heck is this thing doing? This is a really complicated switch. We got this guy contacting the ring, but then we got a slider out here shorting things together. Oh, it's just getting worse. Okay, never mind that one. Go back to this one. 1, 2, 3, 4, 5, 6, 7. Whoa! It's completely turned right around. It's completely turned right around. Yeah, you know what? This isn't working out at all. I'm not getting anything out of this. I need another whole approach to this problem. Yeah. sure do. Another hole approach. Well, there is another approach called that wire is long enough to go somewhere else. Is it supposed to go somewhere else? Or that wire is so short it could only go where it goes. Like, look at this red one that I have attached here. And there's another way to do this too, and that is the easier to trace wires. So wires coming from terminals on things like this one, coming from the volume control. It's easy to find this wire on the schematic and get to there. And go and then start going from there. So I can do a little bit into the switch before I get so far into it. It's components hooked to components hooked to components. So I'm going to turn my attention to that. I'll just try to trace out as much as I can in here. Maybe, whoops, maybe I'll find the maybe I'll find my mistake in there. You know, it has been 3 years since I originally worked on this radio, and just now as I looked in and I saw these two white wires here, a little memory thing kicked in. Two white wires. There was a lot of muss and fuss over these two white wires, if I remember right, trying to get them in the right spot. So I think maybe what happened here, and I'm just making this up, I booped it all up originally and then I unbooped it, but I only unbooped it half, so it still has the boo part even though I removed the oob part. Maybe that's what I'm doing. I've only half fixed my previous error. And also, just to make it even more complicated, many of the terminals on this switch are just spare terminals to make connections to. They don't actually go into the switch in any way, and it's not obvious when you look at them. So this is very difficult to troubleshoot your way through. But I must. Well, it's now the 16th of May. Every day I've been coming in here in the morning and trying to sort out what's going on with this switch. And I can last about a half an hour and then it's over. But today, again, trying all kinds of approaches here to get a breakthrough on some wiring problem or something to do with this tone switch here. I, for the first time, realized exactly how this switch is built. Oh my god, the level of confusion here is really bad. The schematic says the images in the schematic are viewed from the front. Okay, so you have to pretend you're looking this way at these different wafers. There's two wafers, but they have a front side and a back side. They're not related. So there's actually 4 sets of wafer switches in here. What I've come to be aware of just now, let me switch to the other camera. I'm going to kick myself in the rear for this. I mean, you know, like a lot of things, when you see them, they become obvious. So look at the terminals here. Seeing this close up with the camera reveals things that you cannot see from a distance with your eyes. But you see how these are kind of staggered? This one's here, this one's there, this one's here. It kind of carries on like that, sort of. So the terminals on this side of the switch aren't for this side of the switch. They're for the other side of the switch. Here, the back. These terminals pass through and then they do their business on the other side. Oh my. So I only just realized that, and you know what that means? That means I've been looking at this thing upside down and backwards. The other thing is that they say viewed from the front. So you think, okay, from the front, that'd be A, B, C, and D, as noted on the schematic. But it's not. It's A, B, C, and D. These sort of combined confusions just destroyed my ability to understand the switch. So as I'm standing here now, I am for the first time in a much better position to simply try to analyze the switch and figure out, is this really matching with the schematic? That's what's been going on for all this time. my wife commented I have less hair on my head. She was wondering what's going on. So I'm going to get back at it here. Well, what happens to me and what happened to everybody? You can trace something 2 or 3 steps. By then you get into a branch and some other stuff, and before you know it, you lost track of where you were and what you were doing and how it all works. You got to start over and start over and start over. But I don't want to give up on this, because in the end I'm going to find some simple thing, like maybe this capacitor is wrong, in the wrong place. Something simple like that's going to show up. That's what I'm banking on. I'm banking on just doing this literally until the lights come on in my head. Well, here's a good example of what is causing my hair to fall out here. If we look at this terminal, this wire here, this is the feedback wire coming from the output transformer. Okay, at this terminal, it connects to, it's pretty hard to see, another wire, black wire there going down under. That's all fine. But the thing is, this terminal that it's connected to should have a contactor on the back side of this wafer. So when I go to look for it, here's what I find. Oh boy, if I can get this camera on here. Okay, so I'm going to spin around a little bit here. Yeah, what is it you find? Okay, so it's a different contact. I'm wrong. If you follow this one down, this is a capacitor to a wire contact. It's on a terminal that should feed to a sliding contact underneath here. But if you look, you'll see it's torn away. See the other contactor down there. That's what it should look like. And the arm is missing. Now wait a minute. Did that break off, or was that removed during the manufacture of the radio? So which possibility? I guess it could be either, but the more likely one is this was done during the manufacture of the radio. So when I'm developing sort of basic patterns in my head of how these terminals operate, meanwhile they're cutting some away and using them in ways that I just can't reason out. I just can't reason this thing out at all. Wow. Okay, so I guess each one of these things I discover brings me one step closer to finding what the real problem is with this thing. And you could assume, and unless I get a good understanding of what they're doing with this switch, I'm a lost puppy here forever. Wow. Such a simple thing. These switches just, they ruin my day, is what they do. I've gotten absolutely nowhere. And I bet you I put 2 hours of brain-teasing gawking into this. I've gotten absolutely nowhere with it. So one of the approaches I've attempted a couple of times is to assume that what is wrong is not a wiring issue, it's all wired right. I got the wrong size component in somewhere. So once again, I'm going through the various components in here and comparing them to what's installed in the radio, and I have found something quite interesting. It's right here off the volume control slider. The capacitor that's heading to the switch. This capacitor, C32. Come over here. See, C32 should be a 50 picofarad. You know, if it's a 60 or 40, it probably wouldn't matter too much, especially when you see plus or minus 20%. That's a hint that this isn't all that critical, in fact. Let's take a look at what I've actually installed there. That's the capacitor right there, and by my reading it says 500 picofarads. That's the wrong size by a factor of 10. what was I thinking? So you can see the red wire that the capacitor is connected to. Okay, so this is the red wire that goes to the terminal that's been cut away back there. So this is just a connection terminal. And you follow this up, and there it is on the center terminal of the volume control. This other wire, this shielded wire, is the one that's taking the audio through this capacitor and on to the amplifier tube here. The other one is, we'll pick it up again. This red one is coming over to the tone control filter schmozzle. And it's encountering this capacitor. Now let's just see, where's this capacitor supposed to go? This is where the fun starts. So I show it connected to a terminal. I don't show it. It is connected to a terminal coming through from the other side, from the high voltage supply. Oh my. Really? I think so. I think it might be the case that this is high voltage. Oh, why's that terminal go now? Did they cut it or something? No, you can see the arm. Wait a minute. It looks like it's a terminal to nowhere. I just can't quite see it in here. Let me, I'm going to change the focus on the camera so we can see a little better up close. It's going to take me a moment to do that. See, you know, in this kind of work, I go from hopeless to hopeful. When I'm hopeful, I'm quite motivated. When I'm hopeless, I want to go out on my deck and just sit in the sun. Okay, let's try about like that. Keep hope alive. Okay, so we can see clearly it's going to a terminal to nowhere. Wow, really? I have this resistor coming up here. Connecting onto that terminal. Okay, let's just come under here and see if it isn't one of the... I lost track of it. Let's try again. So we're starting from... This is what happens. Lost. Oh yeah, we're following the green wire. I just lost track of what I was doing. It's coming up. Look up to that contact. Yeah. So it's hooked up to a contact, and this is on the. I think this is the A side. High voltage. Well, there is a switch which switches the shield voltage. This has got to be it here, switching the shield voltage on and off on the front end tubes. So when you play phono, the front end tubes are quieted down. No screen voltage. That's what's going on there. So this is a screen resistor or something like that. Brown, black, brown. That's 100. 100 ohm resistor. Ooh, that didn't look too good. Don't look so close. Okay. But this has nothing to do with... Oh, it does, because this capacitor is hooked up to it. Why is that capacitor hooked up there? Oh, not in the wrong size. It's in the wrong place. Did I think? Is there another capacitor in there? On the schematic, I think this one might be it. Well, that's weird. Okay, so we're hooked up to... Whoops, sorry about that. We're hooked up. It scared the shit out of me. It scared me. Let's see. Too many ums. Well, I'm really close to something now. Wrong size capacitor, wrong place. This just can't. Are those really hooked up together? Because this comes up to these terminals which are bunched, which makes sense for what that's doing. And there's that go. I wonder if it should be hooked up to this orange wire. Orange wire. Yeah. Wait a minute, what are we doing here? I'm caught on a wire. So that's just a connection terminal there. This connection terminal for underneath. Oh yeah, right, underneath. Yeah. Well, I'm losing it once again. Capacitor hooked up. This can't be right. This just can't be right. Right there. Oh my gosh. So where we are looking on this switch, we're looking at the 2B side. 2B side should only have two wires connected. These are two white wires. They are connected. The other terminals that have wires, they're probably for the other side of the wafer. Or they're just terminals to nowhere. Or somebody's cut the contactor away. Okay, so we're coming down off the volume control. We're passing through C32, which I'm double checking now, 50, but we saw it's 500 sitting there. That could just be it right there. It then goes down, 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 hooks up to a round of switch contacts. Now, what else is coming into this switch? This one's coming from B minus. This one is coming from this is secondary. What are they doing with this? Oh, this would be the ABC line. ABC down through this resistor down to here. Yeah, okay, go back to where I was. Down through here. That's right. So we have one lead to ABC and the other one to the feedback. Feedback is on the ring. So the feedback going out where this is. Yeah. Help me out on this. So it would appear that this should come down, get on, nothing to do with any high voltage. The high voltage is on here, on the other side. See what happens? I'm just starting to mutter and mumble and move. You know, every time I do this, I just get a little closer, a little closer. What if I just change the 50 to the 500 to 50 and see what happens? Maybe that's all it is. Now, is there a 500 down here? Let's just double check and see, because maybe I flipped 2 around or something. Do we see a 500 picofarad? No. 500. 490 on the gang. 50. No, there's no 500 in here. I think I just made a simple mistake. Well, that's it. That's what I got. I'm gonna try that. I'm gonna change that to a 50 and see what happens to the radio. Well, great. I've finally actually done something to the radio. I have a different capacitor here now. Is that the problem? Boy, if this knocks the problem away, I'll be very happy. Okay, volumes up a bit to start. Make sure we're on the... Oh, well, that answers that question, doesn't it? Okay, so I'm on broadcast band. Okay, no antenna. Antenna. Still got that thing happening there. But ta-da! Well, that didn't help one bit. Okay, I'm going outside where the sun is shining and the birds are singing. Wow, it's really no wonder I can't sort this out. So I'm looking at this diagram. It shows the component locations, but it shows something more. Packed in this area, it shows which wafer is which. And here's the pattern. So this is S2B, S2A, S2D, S2C. So it's C, D, A, B. Oh my gosh, no wonder. No wonder I didn't got this right. And this also indicates a couple of the capacitor positions that should be in there too, which might be helpful. Not so far. Especially when it's pointing right at C41, and what is there is this resistor. But this is original, right in that position. Oh my gosh, I'm just never ever going to sort this thing out. It's never going to happen. What I'm interested in figuring out, there's two white wires that come in down here. I had trouble with these originally. I kept getting them reversed. What are those white wires? They're coming from up here? What's up here? I don't know. Well, another day has gone by. It's now May 17th. Yes, May 17th. And I've been in here periodically throughout the day. Over the last few days, I come in, make a few observations, try a few ideas, try to sort out what is going on with the tone control that it causes this oscillation. Everything I have done to track down wiring errors or anything in here have failed. All this stuff appears to be wired correctly. This has been a horrendous thing to sort out. This is not just your average wafer switch. This is the wafer switch of confusion. This thing. I won't go into all the things that are confusing, but there's a list of things where you can get confused about how the switch is arranged here. So, just out of frustration trying to attack this thing, I took a different tact. Actually, it's not so different. I asked myself, well, what could cause the kind of problem I'm having? And then I go looking for those causes or something. So what could cause this oscillation, this humming and pumping and motorboating and all that? And I thought, well, okay, there has to be an amplifying element in the picture. To get an oscillation, something has to be amplified in order to generate the oscillation. So there has to be an amplifier tube involved somehow. Typically these motorboating things are going on in the IF amplifier or elsewhere, or in a combination. Some, 2 or 3 tubes in a row can get involved in this stuff. So I picked on one tube in particular. It's the one sitting up here. And I looked at the grid. What's going on with the grid? I decided I'm going to test all the components on the tube that may be part of the oscillating picture. And it's very, very simple. There's a capacitor blocking DC from reaching the grid, like there is in many, many cases. And then there's a resistor going from the grid to ground to bleed off or prevent any charge buildup on the grid. So that resistor is usually a large one. In this case, it's 1,000,000 ohms. It's 1,000,000 ohms. Let's test it. Let's test it. So I'm set on the 2 million scale here. My meter's going to fall down, I'm sure of it. Just back these lights up, change the camera a little bit. Okay. 1,000,000 ohm resistor. Still in the circuit, so we should read at least 1,000,000 ohms or less. And it's this guy right here. I put a white clip lead on it so I wouldn't forget this, because I found this last night, late in the evening. This resistor, we should see 1,000,000. Okay, now there's another 1,000,000 right here. Let's just check this one, if I can. 1,000,000. And there's another 1,000,000 right here. Let's check this one. Oh, that's the open one. Still open. It's this one. This was another 1,000,000 right here. 1,000,000. Wow. Wow, calibrate your meter on that one. Let's test this 1,000,000 one more time. This is the bad one. How much is it? We'll put on to 20 million. 20 million. What do you say about that? It'll settle in around 10, I think. 1,000,000 gone to 10 million. Now, is that going to cause oscillation? I can't see it, but it's something that's not right. So I'm going to change it, and we are going to find out if this is the cause of the problem. Make sure I nip out the right resistor here. There it is. Let's make another test. What do you say, Mr. Capacitor, Mr. Capacitor, Mr. Resistor? Yeah, 10. Brown, black, green. Okay, there's no doubt this guy's gone way high. That's 10 times high. So I will get a 1,000,000, I'll stick it in there, and then we're going to play this radio, and then I'm going to go outside in the sunshine again. That's one of the reasons I haven't been posting. The primary reason is that I had nothing good to post. The other reason is I'm going outside excuse me, in the wonderful weather. We just have had fantastic weather the last few days, so same thing today. So let's get this done quick. Okay, probably smart for me to make sure this is a 1,000,000 resistor here before I put it in. That's 1,000,000. That's 11. That's good. That's fine. Okay. Okay, I doubt this is going to fix the radio, but let's just give it a try here and see. In my mind, having, no, that wasn't really an open resistor, it was just gone way high. 10 meg grid leak resistor, 1 meg grid leak resistor, it may actually make no difference at all in the operation of the radio. Maybe they would have put a 10 meg in there if they could have afforded it, but they put the cheaper 1 meg in there. Maybe that's what happened. Who knows? Here we go. quick little safety check. Okay, power on. What are we going to get this time? Volume is above the problem spot. Just get rid of another wire here. Ooh, 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 ooh. What's all that? No antenna, no antenna, no antenna. Yeah, there it is. Okay, full supply. That didn't make any difference, did it? Antenna. It sounds very different, doesn't it? Well, it made some differences. Where did that come from? Yeah, made a difference. This sounds like a bigger engine running now. Well, what does that say? Does that say I'm close? I was close. I was very, very close. It's definitely a little bit different. And I'm not going to poke this sound away. I'm pretty sure of that. Wow, it's consistent now. Phono. So it's consistent now. Maybe there were two things before, and now there's only one. One more for me to find. Well, what I'm going to do is I'm going to review the video that I've shot on this issue so far and see if I can't piece together a video and put something on the internet. Because that's it. I have to come up with another. I got to find another thing to change in here. You know, it's not going to fix itself. Just something has to be changed. So, wow. Okay, well, thanks a lot for watching. If this is the end of this video, so be it. So be it. I'm off to the sunshine. Hey, thanks a lot for watching this stuff.